Pin diode is a diode with an additional undoped region of intrinsic semiconductor. Usual diodes have P and N types of semiconductors meeting at a junction. For pin diode, the I or intrinsic region is between the P and N type regions. The P and N type regions may be heavily doped and used for ohmic contacts. The intrinsic region makes a pin diode inferior as a rectifier compared to PN diodes. But pin diodes are suitable for attenuators, fast switches, photodetectors, and high voltage power electronics applications. Intrinsic region is flooded with charge carriers from P and N regions in what is known as high level injection. Pin diodes will conduct current once the flooded electrons and holes reach an equilibrium point with equal number of electrons and holes in the intrinsic region. While the pin diodes function like a standard diode at low frequencies, it works almost like a perfect resistor at high frequencies, even for large signals. The high frequency resistance is inversely proportional to the direct current bias given, so that if it is suitably biased, it can act as a variable resistor. Because of the wide intrinsic region, pin diode has a low capacitance when reverse biased. In pin diode, the depletion region without charge carriers is in the wide intrinsic region and is larger than in standard PN diode. This increases the volume where electron-hole pairs can be produced by an incident photon. That is how pin diodes can function as photodiodes. In corresponding phototransistors, base collector junction is the equivalent of a pin diode. As the pin diode has low capacitance under zero bias or reverse bias, it will not pass much of an RF signal. With forward bias current of 1 milliampere, pin diode has an RF resistance of about 1 ohm. This can be considered as the on state, and thus pin diode can function as a good RF switch. RF relays, when used as switches, have switching times of the order of tens of milliseconds, while pin diodes can switch in a microsecond. This is quite useful at higher frequencies like in the microwave region and explains the use of pin diode as microwave switch as seen in the image. As mentioned earlier, the RF resistance of a pin diode can be quickly changed by changing the bias current, and at higher frequencies, pin diode acts as a resistor whose resistance is an inverse function of its forward current. This can be utilized in some variable attenuator designs as amplitude modulators or output leveling circuits.